Hello everybody, this is Andy Pilc. It's day 31 of our astronomy unit, and in today's lesson we're going to continue talking about the stars that we can see in our sky. More specifically, in today's lesson we're going to be talking about constellations. Now when I was younger, when I was at summer camp and I looked up at the stars at night, I always thought that the most famous constellation was the Big Dipper, but you'll find out today that that's actually a little bit of a common misconception. It's actually an asterism and not a constellation. So in this lesson, you'll watch these two videos which will explain the difference between constellations and asterisms. So if you haven't done that yet, go ahead and pause my video and watch those because they'll explain it better than me. I'm going to go through the independent work, which is scanning the sky and creating your own asterism by connecting the dots of stars that you can see. And just like kind of ancient civilizations and folklore, you're going to be making a little bit of a story that goes along with your asterism. So let's get into it. When I was looking at this picture, I found it a little bit distracting to look at the lines of the Big Dipper and try to find other shapes. So in order to spice things up a little bit, we're going to go to a different website, and that site is inthesky.org. So go ahead and navigate there. And we're going to use the planetarium to take a look at our celestial sphere that we see. So there's a number of different dials that we can adjust. So first off, we can click and drag the screen around, and you're going to see a number of constellations that are labeled, and you'll see the lines kind of drawing the constellation and the shape associated with it. We can change the field of view. So if I really wanted to zoom in on an area, like maybe, Orion's belt, which is part of Orion the Hunter, is a pretty popular asterism. So I could zoom in as if I had a telescope and decrease the field of view and yet see further distances. But I can also increase my field of view. 120 degrees is about what we have as human beings based on where our eyes are on the side of our head. Let's maybe pretend that maybe we're like a barn owl and we have a 180 degree field of view. So we can click and drag, and you should think about that celestial sphere diagram, right? So this is the sky above us. And you also note the horizon where the ground meets the sky. So that's where an observer wouldn't be able to see any other stars in the sky. And this is based on an observer in New York City. So I'm just going to start off just by facing north. You can click on objects and we can find out more information. I'm also going to mess around with some of these dials just so I can make it a little bit easier to see. Let's close my Google ads. I'd probably look great in that dress, but that's a story for another video. What are we going to show? Of course, we want to show the stars. Let's get rid of the deep sky objects, so no distant galaxies or star clusters. Let's get rid of the planets too and not label them, because even though the planets would move along with the stars in a given night, so we can change the time over here. So as we watch, we'll see, if you think back to when we talked about Polaris, we'll see the sky rotate or appear to move around Polaris 15 degrees per hour, but that's based on the Earth's rotation. The following night, those stars will not be as aligned with the planets will not be as aligned with the stars in the backdrop. They're going to change their position throughout the night, whereas the stars and the constellations are relatively fixed. They change their position in the sky more throughout the year. Well, it changes the position in the sky, but throughout the year, we'll actually be able to see different constellations, and we'll learn why later on this week when we continue talking stars and constellations. For right now, we're just trying to find asterisms. So let's change some of these options here. So for now, let's just get rid of the constellation names and stick figures. Let's get rid of the daylight so that way we can see all of the stars without any light filtering in. And now we can see our stars in the sky. So we're creating, let's get rid of those planets too in the pink. So I'm going to scan the sky and I'm going to try to find a shape. And a lot of asterisms in folklore were named after either gods or parts of the culture. Like, I think a lot of the asterisms that we see reflect the cultures that created them, as you may have seen in some of those videos. My school is in the Bronx, so I want to make sure that the asterism that I create is reflecting some Bronx culture. And I think I found my asterism. Yes, there it is. So right about here, if you see these bright stars, whoopsie, let me try that again. Sorry, I'm not great with drawing with the mouse. I got a lot of them here, but it is this rather ecliptic shape. Actually, I wish I could delete a little bit. Let's go one more time. I think this is going to be a little bit closer to the shape that I was looking for. And if you are from the Bronx, you may have had a chopped cheese before. So that is the big chopped cheese asterism that I found in the sky from my project. And now we can turn on some of these labels and give some information to others as to where they can find that chopped cheese. So it is in the constellations. Let's turn on the boundaries too. So remember, constellations are kind of areas in the sky. They're like regions, and they will have boundaries. Some constellations and asterisms, or some asterisms, can go through more than one zone or constellation. So my chopped cheese is mostly in Ursa Major, but a little bit in Lynx and Leo Minor. And if I wanted to name it, remember that the IAG commonly names their asterisms in Latin. So, of course, I'm going to name it after the Boogie Down Bronx. And in Latin, it would be the Sanctus Descendit. So that's my asterism. Go ahead and find yours in the sky. Once you find it, be sure to share it with your teacher. You can do so either by taking a screenshot and sharing the picture of the map with them, or if you prefer, they also have an export feature where you can kind of download the image and then you can edit it. So I hope you enjoyed this little twist on the independent work today. Let's finish up this video by going over some check for understanding questions. So we have a diagram representing the constellation Ursa Major and one star that's labeled. Letter X represents the location of the Miser 81 galaxy, which can be observed near Ursa Major. The photograph shows Miser 81 galaxy is viewed through a telescope. So we have Phecda with a surface temperature of approximately 9,500 degrees Kelvin and a luminosity of 63. Identify the name of the star on the characteristics of stars chart in the 2011 edition of the reference tables that has similar surface temperature and luminosity. All right, so we're going to go to the SRT. We're going to find a surface temperature of 9,500 degrees Kelvin and a luminosity. When it's saying of 63, it means 63 times more luminous than our sun. So first, let's go to approximately 9,500. Oops, I thought I was able to draw lines. Sorry for my... So it's going to be even here. Sorry for my poorly drawn lines. And then 63 is going to be in between 10 and 100. So you'd figure about over here. So the star in the characteristics of stars chart that this question was looking for must be Sirius. Surely you can't be Sirius. Let's clear the screen there. 2, state the name of the nuclear process. If you watched my videos before, then you should know I love when star questions ask about either the nuclear process or the force associated with stars. But let's read the rest of the question. Occurring in Phecda that produces stars' energy by combining lighter elements into heavier elements. You should know that that's fusion or nuclear fusion. 3, the study of spectral lines from Miser 81 suggests that it is moving towards Earth, unlike a lot of galaxies that we've discussed when they show redshift. Identify the color towards which the spectral lines shift when visible light from Miser 81 is observed from Earth. Well, remember when it's moving away, it would be redshifting. When an object emitting light is moving towards an observer, it means that the light waves are getting compressed, therefore a higher frequency, which means they are shifting towards the blue side of the spectrum. That's all I got for you today. Make sure that you answer up the wrap-up questions, and I will see you next time. Have a good day.